Going to keep on going with this whole quadratic concept. We're solving by factoring. And what does that mean? That means I got a quadratic. We're doing the factoring. Usually, you can factor linear terms and it's all well and good, but factoring is usually done with quadratics. And so if I look at this side, you don't have to when you have two things equal to each other, you don't start out by factoring both sides. But I just want to go over the whole concept again. So you put the blues in the top left, yellows in the bottom right, all the squares are on the corners. So I got 2x squares, and then, I got 12 green ones there and one green one there. That makes 13, so 13 x's, and then I got the 6 little squares. And so that makes a rectangle. Please see, this one over here is not a rectangle. That little piece out there makes it so it's not a rectangle. So this side didn't factor. Yeah, I can't break this apart into anything that makes a rectangle. So that side didn't factor, but this side does. And so now to find out what the factors are, I look at how long is this side of the rectangle. X and an X and a 1 makes 2x plus 1 up here. And on this side, we got an X, a 1, a 1, a 1, a 1, a 1, and a 1. So there's 6 of those. So X plus 6 is on this side. So that's what this factors into. But that's not what we're trying to get. We're trying to find out when are these two things equal to each other. When is the green equal to the purple? So, okay, they're equal. So I have same thing on both sides, so I can get rid of them. So I'm going to get rid of these 3 little yellow squares on that side, and I got to take off 3 little yellow squares on this side. Fine. I got 8 over here, so I'm going to get rid of those 8. Now I got to get 8 over here. Can I do this? I think so. That's 8. Yep. Okay. And then you look at it and go, oh, it doesn't factor, Mr. Stroh. Look there's that little piece right here. It doesn't fit, so that doesn't factor. It's like, wait a minute. There's one more. There's one more thing. You got this option, yeah, it doesn't factor going this way. But there's a couple of different ways to get the blue and the yellows to be together. I can do a 1 by 3, or I can do a 3 by 1. So if I go over here and here, and then spin these guys around, please see, I can make a rectangle. Oh, and there's my rectangle. And what do I get? I got X and 1, 2, 3. So 2x plus 3 on this side and X plus 1 on that side. So there's how you could use algebra tiles to solve this. But I don't expect that you're going to have algebra tiles when you go and do your SATs and stuff. So I need to do this algebraically. So here we go. Purple, green and purple. This is a quadratic, the parabola, and this is a line. And so we're going to try to find out when are those two things the same. So I'm going to go ahead and subtract 8x. I want to get 0 on this side. The whole point is getting 0 on this side. So I'm going to subtract 8x from both sides. And now what do I get? Okay, the 8x goes away. So I'm just left with a 3 on this side, yeah. And then 13x minus 8x gives me 5x. So I got 2x squared plus 5x plus 6 on this side. All right, I still have to get rid of that 3 on the right, so subtract 3 from both sides. Oh, here comes that X box thing. So minus 3 from both sides is going to give me 2x squared plus 5x plus 3 equals 0. Okay, now that I have it equal to 0, I can look at my A, B's, and C's, because this is all about factoring. This little X box is all about factoring, and in order for it to factor, once again, we're finding a place where it hits the x-axis, y equals 0 on the x-axis, so you have to have a 0 on one side to be able to do this stuff. So let's see. Up in the top of my x, I got 2 times 3. Remember, this one times this one goes in the top, so 6. Got it. And then on the bottom, we're going to have a 5. Sorry, a 5. And so what are the factor pairs of 6? 1 and 6 and 2 and 3. Okay, again, because it's all addition over here, plus, 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 I know it's going to be the one with the addition, so it's that 5. So 2 and 3 go in these 2 boxes. All right. Stop it. Go away. Is there stuff down below? Oh, there it is. So what does that give me? Putting it all in. Remember, a 2, and a 2. You start with all that. Put the 3 and the 2 in the numerators. Got it. 3 halves doesn't reduce. but 2 over 2 does. That's 1. All right, and so now there's my factors, which, remember, if I multiply this 2 and I get 2x plus 3, oh, that's one side of that rectangle over there, and the other side was x plus 1, so they are related. And when is this part equal to 0? When is x plus 3 halves equal to 0? Oh, when x equals negative 3 halves. And when does this equal 0? When x equals negative 1. So we're going to call those the solutions. The solutions, looking at it graphically. I think that's what's on my next slide. Oh, yeah, there it is. I went over to GeoGebra. You're going to be doing this week. You're going to be putting in a parabola and a line and finding out where they intersect. Shouldn't be too difficult. So I'm looking for where the green parabola hits the purple line, and I see it. It told me. I didn't have to do anything. It told me. Oh, it hits at A and B. And then if I can go down, can I go down? I look right here. Oh, that one's at negative 1. And this one is in between 1 and 2. I'm going to guesstimate it's negative 1.5. Remember, the graph is only as good as your ability to read the graph. So, I really should zoom in and verify that. But you know what it is. All right, so we're going to try it again. So that's the concept. So I'm going to do the algebraically first this time. So again, I got orange and black on this one. Oh, hello, Sachums. So 8x and 4x. I got to get a 0. I'll get the 0 on the side opposite the x squared. So I'm going to get rid of the 4x. Subtract 4x from both sides. That's going to give me x squared plus 4x plus 15 on this side. And then I'm going to just have a 12. And then subtract 12 from both sides. You get x squared plus 4x plus 3. Oh, I didn't do my A, B's, and C's. Okay, A is 1, B is 4, C is 3. So 1 times 3 gives me the 3 on the top. Bring the 4 down. There's only one way to make 3. It's 1 and 3. So I put the 1 and 3 in here. And when is x plus 3 equal to 0? When x is equal to negative 3. When is x plus 1 equal to 0? When x equals negative 1. So there's my solutions. Those would be called the solutions. All right. And here it is again with the algebra tiles. So, in this one, they both factor. That you don't have to have this be true in order for the final product to factor, but it's nice. And please see that this side factors what? X plus 3 and x plus 5. Okay, yep. That works. And then on this side, we got 4x plus 12. Now, what's this side? 4, and this is x plus 4. X plus 4. Oh, I got too many tiles in there. Ooh, that was going to be a problem. There we go. That's 12 is this row. X plus 3. All right. Now we got it set up right. Excuse me. So, all right. Let's do it again. I got an equal sign in between, so I can get rid of the 4 on this side. And that means I can get rid of 4 on this side. That was 4. I got 12 on this side. And that means I can get rid of 12 on this side. Oh, and look at how convenient that is. I got it, so it finished up in factored form. X plus 1, and this side is x plus 3. All right, and then one more with the graphs. There it is. If I graph the orange one, and then graph the black one, a quadratic and a linear term, the place where they hit are my solutions, and this one hits at negative 1. You can tell that one. That one's nice and easy to tell, and that one hits at negative 3. Now, I have to go with that one more slide. So that's it. That's everything. But what is actually happening when I do this? When I did all my math out, when I did all this math out, what did I do? I subtracted this side from this side. Well, this side's a parabola, and this side's a line. So when I subtract a parabola from a line, it still stays a parabola. So I had to go one more. So if I subtract the black one from the orange one, it turns it into the red one. And please see the roots of the red one, the place where it hits the x-axis, is negative 3 and 1, which is the same places where the orange and the black intersect. So that's what's happening. I hope you got something from that.